All right, let's talk about the real world connection happening here as we are building, evaluating, and interpreting linear functions. All right, so the slope intercept form of a linear function written using function notation is f of x equals mx plus b. To write a linear function that models a relationship, determine the starting value, which is your b or y-intercept, and the rate of change, which is m, your slope, in the problem. They like to use that phrase rate when you're looking for that rate of change. All right, so here's the first problem. The function f of h equals negative 720h plus 10,080 is used to determine the volume of water in gallons in a pool based on a certain number of hours the pool has been draining. What does h represent? What does f of h represent? So let's go back to the problem. Okay, so it says the function f of h equals a negative 720h plus 10,080 is used to determine, they're telling what it's used to determine now, the volume of water in gallons. So they're saying all of that is used to determine the volume of water in gallons in a pool based on a certain number of hours the pool has been draining, based on a certain number of hours that the pool has been draining. What does H represent? Well, H represents the hours that the pool has been draining. What does F of H represent? F of H it tells you, F of H is used to determine the volume of water in gallons. So that is our volume of water in gallons. Now here's the question. How much water is left in the pool after 12 hours of draining? So that means they want you to say that H is equal to 12. Well, that means I'm going to plug it in. I'm going to say F of 12 equals negative 720 times 12 plus 10,080. Hopefully you guys can see me writing there at the bottom. So I'm going to get my calculator. We love our calculators, our best friend here in this course. All right, let's go ahead and minimize that and bring that up. Okay, and you do not put F of 12. Do not put that in your calculator. I'm just going to go in here and get started with negative 720 times 12, close parentheses, plus 10,080. Make sure I put that in there right. And my answer is 1,140. So that's my answer. How much water is left in it? 1,440 gallons is left. And that makes sense because it's draining, so you shouldn't have more, you should have less. So how much is left? 1,440. All right, so notice when I put this in my calculator, I do not put the function notation f of 12. I just put in what it's equal to. Okay, so see what I put in here? And that's your first problem. The end. All right, here's another problem. An 8-inch candle burns at a rate of 0.5 inches every hour. Write a function that models the relationship between the height of the candle in inches as a function of time t. Okay, so we know we're going to use f of t because it says function of time equals mt plus b. So I'm replacing x with t because they said the function of time t. All right, so f of t equals, I need to figure out my slope. Well, it says an 8-inch candle burns at a rate of, well, there you go. That's my slope. My slope is a rate of 0.5 inches. Now it's burning, so that means it's not increasing, it's decreasing. So I'm going to have to say negative 0.5. So even though it doesn't say negative, it's burning. That means it's getting lower. So it's decreasing. So my slope is negative 0.5 t plus, and then b would be the starting height of the candle, and it starts at 8 inches. So I'm going to say plus 8. That's b. And that's how we build the function. After how many hours will the candle have a height of 0 inches? So they want f of t to equal 0. Okay? So 0 equals negative 0.5 t plus 8. So you're not plugging in 0 for t because t is your time, and they said 0 inches. All right, so this is when you can use your calculator to help you with that. Where's my calculator? Did I close my calculator out? No, hold on, gotta reopen my calculator. How could I close out my best friend? I need my best friend. All right, so let's pull this back over here. All right, so I'm gonna go ahead and put in the function. I already know what my function is. I'm gonna say y equals, I'm gonna graph it, y equals negative 0.5 x. I'm gonna put back x because I'm graphing it, plus 8. Okay, so that's what it looks like. So you can look at the graph visually to see. It says after how many hours, I'm looking at my x-axis, will it have a height of 0 inches? So it'll be 16, right? So t would be 16. Another way you could do that, say the graph is not looking too good and you're like, this graph is just not making sense. What I could do here is I can open this up and I can go in here and I could go on the gear icon. So again, I'm going to the gear icon and I could say, give me a table of values. And I could keep pressing enter, 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 enter to give me all the table of values until I see my y value of 0. And then my x value is 16. So again, I put my equation in there. I click the gear icon. I say, give me a table with that for that equation. And then I press enter, 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 enter. Okay, and I go all the way until I see the y value of 0, and my x is 16. So after 16 hours, my candle would have burnt down. There you go. Now it's your turn. Pause the recording. Go ahead and give it a try. Andrea conducts a science experiment and observes that the height of a plant depends on the amount of sunlight it receives. The plant's height is 37 centimeters and it grows at a rate of 0.004 centimeters per hour of sunlight. Write a function that models the relationship between the plant's height in centimeters as a function of time, t in hours. Explain what f of 12 equals 37.048 means in terms of the problem. So pause the recording, go ahead and give it a try. All right, so it says write a function to model the relationship in the plant's height. So Andrea conducts a science experiment and observes the height of the plant depends on the amount of sunlight it receives. The plant height is 37 centimeters, so we know it's starting at 37 centimeters. And it grows at a rate of 0.004 centimeters per hour. So again, we're going to say f of, I could say, it doesn't say t, so I'm going to say f of x equals mx plus b. Remember, that's what we're using. The slope in this case is growing at a rate, so it's increasing 0.004. That's my slope. And my y value is where it's starting, so that's 37. The plant's height is 37. So my function would be f of x equals 0.004 x plus 37. All right, and that's it. Oh, they said in times of t hours. My bad. I knew there was some variable there. So redo f of t equals 0.004 t plus 37. Okay, that's my fancy t, so you don't think it's a plus. They did say t hours. I explain what f of 12 equals 37.048 mean in terms of this problem. It means when the time is 12 hours, the plant will have a height of 37.048 centimeters. I've also seen students say that after 12 hours, the plant would have grown 0.48 centimeters, right? Because they took the 37 and they subtracted it, right? So you could say, or grow 0.048 centimeters. All right. That's an advanced explanation that it would have grown by that much. That's an advanced explanation. All right, so this is a real world connection to building, evaluating, and interpreting linear functions. If you have any questions, please let your teacher know. Remember, you can rewatch this, okay?